Hello everybody. In this video I want to briefly explain the difference between exponential growth and what is generally known as logistic growth. So how do these two things differ from each other? Well, in the exponential growth, what we see is that the growth curve of a population, so here population versus time, when we plot that in an exponential growth, we see something like that. So as time goes by, the population grows and grows and grows and grows. And the exponential growth is characterized by this equation here, where we have the growth of the population or the population number at a given time equals the starting population. So that's the population at the start time, times e to the power of k times t, and k here is our growth rate. Or growth rate constant, I should say. And obviously t is the time at which we look at it. So that's the exponential growth. Now, the difference to the logistic growth is that when we look at a logistic growth, we don't see unlimited growth. We see a typical sigmoidal shape of this curve. And here again, we have our starting population. So again, that is start. And we also abbreviate that with P0. But what we see is that the growth does not go ad infinitum. We see that we reach a sort of a plateau. And this plateau is called the carrying or maximum capacity. So carrying or maximum capacity of the system. Now, we don't know for human beings where this maximum capacity is. We have to obviously figure that out at one point. And just simply let's go back to our equation. Very often this carrying capacity is abbreviated with a capital M. So in our equation that describes this logistic growth, we have again our start. M is the maximum capacity. And K again is our growth rate constant. And obviously this equation looks a little bit more complicated than the exponential growth, but it's just simply a different form of describing actually how a population would grow more realistically. So that's what we see here. And very often we find that bacterial cultures actually grow according to the logistic growth as described in this equation. So I hope this makes sense, and thank you very much for watching.